Hello, and welcome to this FMSP online revision session. This session is looking at the MEI Statistics 1 specification, continuing with the binomial distribution and looking at hypothesis testing. We'll start by looking at the specification. These are all the parts of setting up and carrying out a hypothesis test. You need to understand the process, be able to identify appropriate null and alternative hypotheses. You need to be able to conduct the test at different levels of significance, be able to identify the critical and acceptance regions and draw appropriate conclusions from this. You also need to understand when you want a one-tail test and when you want a two-tail test. So some key vocabulary that you need to know. The null hypothesis, this is the status quo, this is the situation that you have to start with. Generally speaking, in the question, there will be just one probability given, and that's what you go with for the null hypothesis. The alternative hypothesis is what you think is happening now, and you have less information about that. You might suspect that the probability of success is going up or going down, or maybe just different from your null hypothesis. If your result is less likely than the given significance level, it is significant and you will reject the null hypothesis and go with the alternative one. One tail or two tail. If you think that the probability is getting lower, then your alternative hypothesis will be that P is less than whatever probability you're given. If you think that things are becoming more likely, then your alternative hypothesis will be that the probability is actually higher than the given probability. And in both those cases you have a one-tail test. In a two-tail test, we simply say that the probability is different from the given probability. And in that case, you need to halve the significance level when looking at the two tails. The critical value is the point at which you reject H0, and from that you get a critical region, which is the set of values for which you reject the null hypothesis. And conversely, the acceptance region is the set of values for which you accept the null hypothesis. So here are the steps that you follow in carrying out a hypothesis test. First of all, you establish your null and alternative hypotheses. You need to decide on a significance level, although in the exam this is always given to you. I say always, I haven't seen a question where it hasn't been given to you. If one should happen to turn up, then 5% is the most common value chosen, and that's what you should use. You then collect the data, which of course will be given to you in the exam, and then you conduct the test, remembering that if it's a two-tail test, you need to halve the significance level at each end. You then need to interpret the results in terms of the original claim and present your conclusion in the context of the problem. And these points are essential if you're going to get full marks for the question. A lot of people struggle with deciding whether they need to reject or accept the null hypothesis. You've made your calculations based on the null hypothesis. If the data that you've collected has a very low probability given the null hypothesis, it's very unusual, then that would suggest that the null hypothesis looks wrong, and that means that you've got sufficient evidence to reject it. And a few key points for making sure that you get full marks. Make sure that you define P carefully when you are stating your hypotheses. Make sure you give your conclusion in the context of the problem. Don't just say, accept the alternative hypothesis. That won't get you full marks. It will get you some credit. And importantly, couch your conclusion in somewhat indefinite terms. The evidence suggests that, or there is insufficient evidence to suggest yet that. You haven't proved anything. All you've taken is a sample, but that sample will provide evidence towards a decision. So the first thing to note is that these questions tend to be very long. They come towards the end of the paper. And the first parts of the question are often straightforward applications of the binomial distribution. It's a very good idea to read through the whole question carefully first and highlight the key points. So the first bit is just telling you what a no-show is. And then at a particular hospital, on average, 15% of patients are no-shows. That's going to be the crucial number. We've got a random sample of size 20. And then we've got to find some probabilities, exactly 1 no-show and at least 2 no-shows. Then we are looking at changing the situation. The hospital management introducing a policy of telephoning patients before appointments, and it is hoped that this will reduce the proportion of no-shows. That's important. That's going to give us the form of the alternative hypothesis. They then do a random sample of n patients and hypothesis carried out at the 5% level. What you have to do is to write down your null and alternative hypotheses, and it says give a reason for your choice of alternative hypothesis. We're then given a value for n and 1 no-show in the sample and asked to carry out the test. And then we're given a situation n is large. We're not told what it is, but we are told the critical value for the test, so we don't need to know that. And we've got 6 no-shows, and you're just asked to complete the test. And then to look at the case where n is less than 18 and explain why there is no point in carrying out the test at the 5% level. So we'll have to wait and see when we get there what that shows. Okay, to start with, it's straightforward binomial distribution calculating probability. So we'll define x is the number of no-shows in the sample. X is binomially distributed, sample size 20, probability of a no-show 15%, so 0.15. And then part 1a, probability x equals 1. 20 choose 1. 1 success, 19 failures. Okay, I'm talking in terms of success being the thing that we're interested in, although clearly in the context of this problem, a no-show is not a success. And calculating that, 0.1368. And for part B, probability that x is greater than or equal to 2. And it's always easiest to convert that to the end that's smallest, so we'll say that's 1 minus the probability that x is less than or equal to 1. Look that up in the tables, and your answer is 8244. Okay, moving on to the hypothesis test. Importantly, to start with, we need to define P. So let P be the probability of a no-show. And that the implication there is in the whole population that's being studied, not just in your sample. Our null hypothesis is that nothing has changed. The probability is equal to 0.15. Our alternative hypothesis rests on this word here, reduce. They are hoping that the probability has gone down. So our alternative hypothesis is that the probability is less than 0.15. And take care. It says give a reason for your choice. We're not finished yet. We haven't got all 4 marks. H1 has this form because the hospital management is trying to reduce the proportion of no-shows. Okay, so now we carry this out. We're still with x being binomial 20, 0.15. And we've got a sample size of 1, so we're interested in the probability that x is less than or equal to 1. And we did look that up earlier, and it was 0.1756. That is bigger than 5%. It's not significant. So accept H0. Now we need to put that into context. There is insufficient evidence. It's not that there's no evidence, because we've certainly got a lower proportion of no-shows than we would have expected if the probability was 0.15. So there's some evidence, but there's not enough evidence given the natural variation in random events. So we say there is insufficient evidence to suggest that the proportion of no-shows has decreased. It might have done, but actually you could have got that result with natural variation with the overall probability remaining unchanged at 0.15. We then have no-shows 6, and the critical value for the test is 8. So for this one we note that 6 is less than 8, so it is in the critical region. If it's in the critical region, we reject H0. And we say there is sufficient evidence. But notice that we don't say to say that it's reduced, we say sufficient evidence to suggest that the proportion of no-shows has decreased. So we can't be sure. Again, we could have got this result by natural variation, but the fact that it's in the critical region means that the likelihood of getting this result, if it hasn't changed, is under 5%, and that makes us think that, well, probably the proportion has reduced. And finally, for n equals 18. So for n less than or equal to 18. And if you look in the tables book, you will find that the probability that x is less than or equal to 0 is actually bigger than 0.05. So the critical region would be less than 0, but you can't have less than 0. So there is no critical region, or you could say the critical region is empty. And therefore you cannot carry out the test with fewer than 18 people. Well, 18 people is clearly not enough to be representative to give an idea of what's going on. Well, that is all you need to know about hypothesis testing, which brings these MEI S1 videos to a close. I'd like to wish you all the best with your exams. Goodbye.